This is example 3, and it focuses on that part of the quadratic formula that is under the radical. So we have our negative b over 2a. Over the past couple days, I've been writing this in a different color because I wanted it to stand out, that b squared minus 4ac. Let's read what it says right in here. Okay, if that b squared minus 4ac is greater than 0, then the quadratic will have two real roots, two real solutions. So if I can take this magnifying glass over to here, look at that red parabola. Notice how that's an example of one that would have two real roots because it crosses the x-axis twice. And you can see them on this coordinate plane. So that red parabola must have had a discriminant that was positive or greater than 0. The second one, where b squared minus 4ac equals 0. It says, then the parabola would have one real root, and that would look like the blue one that we see over here. One real root. It just comes down and touches the x-axis in one real spot, one location. And then finally, b squared minus 4ac less than 0. That means that it's negative. So think about that. That would mean that you would be square rooting a negative number in the quadratic formula, right? Right down here. If that green part was negative and you tried to square root it, I, the imaginary unit, would show up, meaning that the parabola, like this green one that we see here, would have no real solutions. They would be two complex solutions. So this page is pretty important. I want to put a star by it. The number of real solutions can be identified or determined by the discriminant. So let's see that in action with the triad here. All we have to do is check b squared minus 4ac. They're not asking for the solutions. They're just asking you to say whether it is two real solutions, one real solution, or two complex solutions. That would be if the discriminant is positive, 0, or negative. Just a little checklist. Check this versus this versus this, and you can tell me how many roots and what kind of roots it would have, how many solutions. So let's go here and do b squared minus 4. A is 16, C is 1. Everything goes in the spot there. How about this one? B squared minus 4. A is 2, C is 6. Let's see what we have. I think over here we have a 64 minus a 64, which is 0. So this parabola, this 16x squared plus 8x plus 1, where does that equal 0? I bet it comes down and just hits, it'll be more like this, in one location and then bounces back up. All right, so your solution here would be to say one real solution, because the discriminant was 0. In this one, we have 25 minus, this is going to be a number larger than 25. It's 48. 8 times 6, 48. So you get negative 23, meaning that this parabola would be floating up above the x-axis. There would be no real solutions. There's a gap there. Doesn't hit the x-axis. Since this is negative, you would say two complex solutions. And that's really it for example 3. Just pop it in the discriminant, tell me how many solutions there are, and move on with the next problem.